Okay, introducing Euan Norris. Hopefully he's still here. There he is. Head of Smart Cities at Scottish Power is going to take some time now and go through the role of Scottish Power as it relates to energy storage, and I think touch on a couple of different technologies at various stages of maturity and application in the area. So I will hand over to you, Euan. Welcome.
Okay, thank you. Thanks, everyone. As Dan said, Euan Norris, Head of Smart Cities, and I think one of the things that I get asked each day from colleagues is, what does that really mean? What does that really mean in terms of smart cities? And my answer is quite simple in that it's trying to take everything in the future energy market and bring it together as a whole system approach. So as a smart solutions team, we have mobility, which is looking at the evolution and transition from ICE vehicles to electric vehicles. So we look at public charging, we look at home charging, fleet charging, business charging. We also have a team dedicated to looking at solar and battery storage, and that's both in people's homes and in a business context, but also making significant investments in renewable generation where people can buy that power directly through kind of on-site or off-site PPAs. And then we've got our heat team, again, very focused on the home, heat pumps, air conditioning units, but we're also now transitioning, looking at industrial heat solutions. We've had a lot of conversations with industries who are looking to transition away from gas and trying to get the kind of high temperature heat. So again, the team are involved in establishing those capabilities. The other side of our business is actually in the home. So we do a lot of home energy management, trying to help people with energy insights, trying to help people actually manage their day-to-day energy consumption, which is obviously becoming more to the fore given where we've been in the recent energy crisis, or the current energy crisis, in terms of cost. So my role in cities is to try and combine all of that for organizations, and cities sometimes pigeonholes you into thinking large cities across the UK, but it's actually working with communities, large businesses, SMEs, and a lot of industries to try and support them in the energy transition. And that's as well as planning it and then moving, once we have deployed assets, to hopefully managing it, and flexibility is going to obviously a key part of the future energy mix. So a bit of what I'm going to talk about today is just as I'm going to start to share my screen. So hopefully you should see that coming through now. Even a wee hint, if you can see that, would be good.
Nope.
You not see that? No?
No.
Okay.
That's better.
Okay. Okay, good. So what I'm going to just touch on today is the role of energy storage in the future EV and energy market. And I think, before we get into the conversation around energy storage, I think we've got to put it into the context of where we are and why is flexibility so important. And recently I attended one of National Grid's Future Energy Scenarios workshops, and they painted the picture very, very clearly in terms of where we need to go in a future energy market. There is a huge requirement for flexibility in our energy market. The technologies that we're trying to connect to the network, the way we're trying to transition away from fossil fuels to renewable generation, which is intermittent, we need to be able to then match our demand and supply, which we've never had to do previously. And I think one of the things that we're very blessed with in Scotland is certainly the amount of renewables that we do have in this area. However, one of the issues that also comes about is the charging mechanism. So, a move away from the current regime to more locational charging signals is really important to make sure that people are incentivized to locate renewables and demand in the right areas, so that we're not trying to transport huge volumes of energy across the country. But again, that's a positive in relation to how we're developing our market, moving away from fossil fuels. And I think one of the final points, and I think we were all touched with that, is we need to improve the penetration of participation and flexibility in the marketplace. And we're looking at it from a domestic customer right up to a huge industrial customer as well, supporting them to take more control of their future energy needs. As a Scottish Power, a traditional energy supply business, well, actually, you know, what myself and my team are doing is we're trying to say to our customers, you can take more control of your future energy. Try and mitigate your exposure to future energy rising costs if you can invest. Obviously, it's not insignificant sometimes in terms of investing, but it's trying to help businesses and our, you know, domestic customers transition to take more responsibility and have that enabler to take more insight into their own energy requirements. So, in the context of those three things, just building on that. This is a graph. It looks out to 2050, and it just shows the kind of dark yellow where, you know, renewable generation will be, and looking at that demand curve. So we can see it doesn't correlate directly. So demand flexibility is going to be really important in our future energy market. So looking at EV vehicles and looking at smart grids, looking at storage. When you look at the flexibility in terms of demand side response, you can see that you know, that we're anticipating that by 2050, we'll be looking at just under 12 gigawatts coming from smart charging. Smart charging can take a number of ways, obviously, in terms of, you know, public charging, but home charging. Putting your vehicle into a position where you know, you want to have it charged overnight. But you're not in control of the network, or your supplier can control it. So it's quite an interesting shift when you look at the future energy market of where the expectation is in respect to, you know, that demand side response activity compared to where it is today, which is probably more towards the I&C processes and I&C heat. So it's quite a transition that we're seeing, obviously, in the current energy market. So in the context of electric vehicles and public EV charging, and I think it's probably a good point to put in a little bit of an anecdote and a personal experience. So I'm not an EV driver as yet. I do intend to become one in the near future, but just a few months ago, I had reason to be down in Farnborough at the Fully Charged show, and that's the first time I've taken an electric vehicle on a long distance, and it was the best thing I ever did in terms of the experience, the charging network, understanding not the range anxiety. The car was fantastic. It was getting to the charger and will it be available anxiety, and then when it is, will it actually deploy the power that I needed in a reasonable amount of time. And that map on screen there, if you look at it, you would think we've got a fantastic penetration of chargers, and I think we do. We're starting to increase it, and I think the challenge that we're facing in the industry, and it's same for ourselves, is that, you know, the way we power our vehicles today, if we go to the petrol station, we have to travel somewhere, put petrol in our vehicle, and then we move off. But we know that generally when we need petrol, it's there. EVs take on a different, you know, completely different connotation for us, because actually we have the capability to charge at home, but the public infrastructure is going to be critical for those who maybe don't have access to home charging or have got on-street parking. But more importantly, from a battery storage point of view, you know, we don't have it needs to complement the EV charging going forward, particularly in the public arena. And going back to my story, one of my frustrations when I was coming home, it took a 6-hour journey, took about 12 hours. And that was all down to having to stop twice for a charge. And then the first charge took me probably about 2.5, 3 hours, because A, it wasn't available, and B, when it was, I was able to plug in, it took an inordinate amount of time because I wasn't getting the power that the device said I should be able to import into my car. So charging, at the moment, the infrastructure isn't there, and the infrastructure is not there from an electrical point of view. So from what we're doing is looking at not only deploying charging for a public arena, first of all, making sure that every time one of our customers plugs into one of our chargers, they get the power at a rate that dispensed at the rate that we advertise. And one of the things that we're going to have to look at is deploying storage to complement that, whereby we can use the existing infrastructure, because one of the other issues that we're experiencing is the time and the economics to actually get the appropriate infrastructure to supply the chargers. But actually, going back to my point in flexibility, we can make better use of the pricing that's in the current landscape of the energy market today. When the wind blows, or if it's a really sunny day, pricing generally is positive, i.e. it's cheaper. And then when it's slightly supply and demand, how we can then support our own charging regime through battery storage is going to be critical to making that an economic solution going forward. And we're already seeing some operators and cost parity between petrol stations and the charges for car charging as well through electric vehicles. So the importance of storage from a public point of view is not only just to manage that arbitration in terms of the energy market, but also to actually ensure that we can deploy it at the rate that is necessary to meet the uptake in EVs that we're expecting over the coming years. So storage for me in the public charging regime has to go hand in hand with EV charging, particularly in more rural areas, particularly when you're looking at sites where there's a large volume of clustering effect, like a roadside service station, things like that. And again, how that can complement with other technologies is going to be really important. But what I would say is, I do think the infrastructure is starting to grow, and it's about not just being there ahead and being fast. It's about making sure the infrastructure is usable and that customers get a good experience when they go and charge their vehicle and they're not in there for hours. But as I said, from my point of view, on a personal basis, driving up and down to Farnborough a few months ago was one of the best things I did, because it did change my view in terms of how we as a business need to ensure that our rapid chargers are rapid. We don't skimp on power to a charger because we're taking a lesser connection or it's been there. That's all that's been available. We make sure we put in the solutions that support the charging infrastructure we're putting in. So again, I've probably went on a wee bit here. This is probably just a kind of summary of what I just said. Storing energy in quiet periods to provide high power charging in busier times is pretty self-evident. We have to. That's the model that we need to follow if we're going to get it at scale, as well as harness a renewable power that's coming forward, because the wind doesn't blow overnight. People talk about time of use tariffs at the moment, and everything goes at night time. Well, if actually we all start to charge our vehicles at night, that'll become a peak period. And actually, as we move away from fossil fuel generation to more intermittent renewables, then actually we need to have a dynamic shift in how we import and use power. There is also future revenues by deploying some of that, so it starts to mitigate against some of the increasing costs that we're seeing. So if you put an EV charger in a public arena, you've got storage, well, that can actually support flexibility services, and the provider can then use that to subsidise some of the charging infrastructure and the end cost to consumers. So again, these are things that are starting to come to the fore. It's adding a value potentially to the local and national network. So that infrastructure actually becomes a more useful asset, as well as providing a very essential service in the public charging arena. So from a public point of view, we see in certain areas EVs rollout really important, but complementing that with technology such as energy storage and again a significant size of energy storage, so that you can provide an appropriate rapid charging, particularly in the public arena. And it's not dissimilar when we move to the role of home energy charging. I think one of the things that we've seen a huge uptake in the last year is the amount of people deploying solar in their homes. We're inundated, if I'm honest with you, with people inquiring to put storage in their homes, and actually our order book is probably 4 times the size that we expected at the start of the year when we launched our solar business. One of the more interesting facts in thinking about storage is when we were taking forward that solution, again, this was before, we're talking maybe 12 months ago, we were unsure how storage would, people's appetite for storage. And now we sell 70% of our solar installations have a battery alongside it, and again an optimization tool. And we're seeing people, making that transition first, looking at solar storage with a view to capturing that and using it when they actually buy their electric vehicle in the coming weeks and months. And if anybody has tried to buy one in the recent months, you are looking at maybe 30 to 70 weeks, depending on the vehicle you're trying to buy. So we're seeing that transition in the energy, home energy market, and storage is going to be critical for all the same reasons that I spoke about in the public arena, because we're moving away from that traditional way of generating power to a more intermittent, weather dependent source of power supply. And again, in our homes and in businesses, we need to think about how we consume and procure power, and storage will have an important role in that. But I think from in the home point of view, it's certainly got to be part of a whole home energy management system. And I think one of the things that many organizations are grappling with, some are further ahead than others, is how do you optimize power in an individual's home. I look at my own home, I've got PV in the roof. Storage doesn't just come in battery storage. I've actually got thermal storage, in terms of the water heating, and can deploy some of my solar into my water cylinder to provide an ambient temperature and reduce my reliance on gas, which I've done already. When I get my EV, then it's how do I make best use of that power in the home? How do I avoid exporting anything from my PV array if I'm not capturing it in my battery, if I'm not capturing it and putting it into the home? And vehicle to grid is something that people talk about, and there's been lots of trials in relation to its value. And as I touched on in an earlier slide, National Grid certainly see that vehicle to grid being a huge proportion of the demand side response activity out to 2050. But what we really need to do, the vehicles, the technology has the capability. What we need to do is a seamless ability to interface with that, so that customers are more opt-in, not rather than an opt-in. It's an opt-out process where they give over the management of their energy supply to their energy supplier, and they trust them to manage energy in the most optimum way, using the in-home storage, using the car, using what their devices they have in the home. And these are the things that we as an energy supplier are now focusing on. It's about, it's about technology to support people's lives. It's about technology to optimize their energy use. And it's about actually supporting them to minimize the reliance on the wholesale market, if you like, by deploying the assets in and around their home. So that was a very whistle-stop tour around things that we are doing around the energy end-to-end energy market. And welcome, I don't know if there's a Q&A now, but I'd be delighted to have any questions and support. And actually see if there's anybody disagrees. That would be an interest, make it a little bit interesting for the final session as well. But thank you for the time and the opportunity to present.
Awesome. Thank you very much, Euan. Really appreciate it. That's really interesting, sort of looking at when we expect to sort of see these different types of storage come to the forefront. It sounds like we're not quite there yet. We are happy to take a couple of questions. If anyone in the audience has a burning question there, please just pop it in the chat or the Q&A box, and we'll get to that. But I just had a thought, I guess, and an observation with that last slide. I don't know, it makes me a little bit nervous. I'm happy to go around and replace my own light switches these days, but all of a sudden I'm becoming burdened with a whole lot more energy related stuff that homeowners didn't have to deal with before. So all of a sudden I'm doing generation and storage and management, and it's like, this seems really hard. So.
I think you're right. And I think, there'll be, people, if I look at the energy net system today, if you look at the fully charged audience, when we went down there, and that's where my anecdote came from, the Farnborough EV journey, I was down at fully charged, and they do not, those are individuals that are pushing you to actually bring out technology to make their life. They're already ahead of the game. And we've got many customers who are, probably a bit resistant even to get a smart meter. But we need all those elements to actually make this transition work better. And one of the issues that we're facing is that from a networks point of view, networks have done studies, and because of the way that we're starting to implement low carbon technologies onto individual homes, which were never designed to do that, there can be restrictions and constraints very quickly in a street if you get a clustering effect. So having that ability to manage through having storage, making use of the assets in the home and any flexibility also enables us to keep that penetration of low carbon tech, continuing, which is quite stark, but it's a reality, because we every time we install a solar or an EV or a storage device, we have to ask the DNO's permission. And there are occasions when they say no, it can't be done. So that's not right for that individual consumer, because it's unfair. But so we need to come up with the solutions and give the DNOs comfort that we can manage the power flows and not affect their wider network as well.
Got it. It sounds like there's an opportunity there for many new business models to help address those opportunities. So Rory, one of our previous speakers today, I think has a few questions. Rory, if you want to turn your mic back on. Yep.
Yeah, my mic's on. I can't put my video on, but as long as you can hear me.
It's all right.
Okay. Yeah, I had a couple of questions. It was really, really interesting. Just listening to that and taking a few notes. And I guess I'm naturally inclined to think how my business model could fit with that, which in my head is quite well. But I'm going to ask a question about your plug-in chargers and roadside chargers and the strategy there. I mean, you showed that Zap map picture of the landscape and the tens of thousands of EV chargers around the country. I'd argue that probably about 60% of those are about obsolete already. They just,
you're right, Rory.
I was going to say, sorry to jump, but the question really is there any kind of governance or standards, or is there any influence there around modularity and trying to think, instead of just putting a site in, that's it for the next, you're thinking, okay, how do we replace 5 years? How do we make it so easy enough to replace, so when the new standard comes in, we can chop and change it quite quickly? You're
absolutely right. I think, one of the things that when we're deploying anything is we have to take a 10, 15-year view. And let's be honest, the equipment you do put in today, technology is advancing so quickly that it might be obsolete reasonably quickly, but it shouldn't be. It might not be the latest, but it shouldn't be obsolete in terms of providing service to the EV driver. A good example is the contactless payment. That's going to be mandatory coming in. And if you think of the apps that you need to have if you've got an EV driver, me personally, I don't need an app to go to the power, to the service station. I just pay with my switch, and we have to make that a seamless transition for people going from ICE to EV vehicles. There is regulation, and again, there is regulation coming forward. But what I do agree with is, going back to the point about storage, one of the issues is that there isn't a lot of capacity available in the network. So people are putting in EV charging, they maybe put in 10 chargers when they can really only supply 5 of those, and then they trickle charge the rest. That to me isn't a good customer experience. So again, when we're doing something, we'll only put in a volume of charging that the capacity is available for. So instead of putting 5 in, we might put in 2. But actually, when we actually reinforce that, we might actually use the same supply, the same connection, but we might back that up with some energy storage. So we trickle charge the battery, and then we can provide a bigger boost. So there's a whole host of things that are ongoing. That's the reason why I showed the map. If you looked at the map, you think it's brilliant, but actually we know there's quite a way to go, and we're quite at the infancy. But I do agree. I think it's very difficult to always have the latest technology out there. And let's be honest, there's a huge capital investment. So there's possibly a 5 to 10 years of that asset being in the ground before you get your recovery, your cost, and make a margin. We shouldn't shy away from that. So we can't chop and change those assets after every 2-3 years. So there's a business case got to be done for that as well.
Yeah, I was just trying to think if there's any discussions about influence the design of the actual physical chargers, so they can be, you know, in the 5-10 years, once they become obsolete, you can actually swap them out easily for the next generation.
Well, I think that they can. They are modular. The only thing that actually limits what you can put in is the connection, and basically it's a cable. The cable's already there under the ground, and it's that would be one of the things. And I've spoke to Dan about this on a previous occasion. I used to work in a networks business, and if MD's putting in charging today, well, don't think about the 3 chargers or the 5 chargers you're putting in the 200 space car park. If that's a new car park, put in the ducting for that future. And that's the biggest cost, is the civils, in terms of putting in some of these chargers. So you can future-proof it by looking at the infrastructure. You might not be able to put in the huge amount of chargers today, but you certainly can put in the connection, the transformers, and the infrastructure. And these are the sort of things that can bring down costs for future and quick deployment as people in usage, you see that usage upturn. But yeah, as I say, I agree with you wholeheartedly, but there's also a reality when you put in a charger, it's got a lifespan in terms of trying to get that investment back, which is not insignificant.
All righty, thanks for that. Sorry, we're gonna have to wrap up here to make sure we finish on time, but thanks, Euan, really appreciate it. Some really good content there, and it's good to understand sort of the status and role of where that kind of wholesale and distributed storage is going to play in the network going forward.